going to talk about our curriculum math program, which we are running for the third time this year. And we are currently offering for our pupils in years 4 to 8. But before I start, I would like to tell a few words about myself. As a child, I love mathematics and experienced very different types of learning myself. So there were math circles, there were correspondence courses from major Russian universities for school children. There were popular math books and magazines. I was also studying in a boarding school in math in Moscow, which specializes in mathematics. I graduated from Moscow Institute of Physics and Technology quite some time ago and have been teaching ever since. I worked with pupils of all levels. At one end, there were pupils who, according to their teachers' opinions, would never catch up, and they did. And at the other end, there were child prodigies and math Olympiad winners. I worked in state schools and private schools. I worked in full classes, in small groups, and also one-to-one. I prepared my students for university entrance exams in Russia. I helped them with the preparation for their American SAT tests and also for French baccalaureate. So as you can see, I have quite extensive experience of both learning and teaching, and it certainly helps me with my current job. So in curriculum math, we cover all essential school topics, focusing first of all on mathematical reasoning rather than technical skills. We thoroughly explore each topic, trying to encourage the children to make connections between what they already know and what they are currently learning, and to build their understanding on these connections. And we offer some standard questions, but also some non-routine, challenging tasks that certainly will help our pupils with their with more advanced mathematics that they will meet later in school or maybe outside of school. So I'm ready to show you some examples of questions and tasks the pupils did over the autumn term. It's quite a lot of material, but I won't give you detailed comments. I want you to get some general idea of what we've been doing. That's year 4, the youngest ones that we're dealing with. We start with some simple tasks on visualizing numbers on the number line. I think visualizing is an important tool for understanding mathematics and for acquiring some kind of number sense. And unfortunately, it's not in favor in most schools right now. So another task, again, we don't focus on getting the answer. We focus on understanding which sum will give the greater answer, and this relies on pupils' knowledge of properties of arithmetic. Well, this is the task of finding components of round numbers, which is again overlooked in schools usually, but it is important if we want them to develop their mental math skills. We, of course, try to find some shortcuts and some rules they invent how to do that quickly. That's the word problem. We do word problems. However, this is an inverse to word problem because there is a solution and they need to make up the problem themselves. The trick here that it can't be done if they just substitute numbers without thinking. This is quite a tricky question, and we spend some time reasoning about what was the question and would it be correct to solve it like this. Once again, year 4, number lines, but here we are preparing them for working with arithmetic sequences, which normally they only do in secondary school. But here I think it's a good starting point. They develop the idea of equal gaps between the numbers, and also practice some tricky questions where they need to find the midpoint between two numbers. Again, as I said, it's all about connections between what they know and what they're learning. So they already know 50 plus 50, everyone knows that. 49 plus 49 could be found easily from there. We don't forget about geometry. The spatial skills are very important on their own, but they also help with calculation techniques, amazingly, surprisingly, but this is true. And this is one task where they need to appreciate that the same shape could look very differently, and they need to find the solution. Sometimes there are a few different ways of doing that. Similar question again. It's kind of a puzzle, but there are some ways to solve it by thinking, not just by randomly trying different options. And we talk about this a lot. Multiplication is the primary topic, the major topic in year 4. And here we try to go back to basics and explain why is it that 3 times 7 is the same as 7 times 3? It turns out a big revelation for some children. We build our multiplication tasks on the array model, where multiplication is the result of finding area of a rectangle. Once we have these geometrical tools of rectangles, it's easy to answer questions like that. And again, it's about connections, it's about properties, not about getting the answer as quick as we can. I think that's it for year 4. That's what they covered over the autumn term. Year 5, we're working mostly on fractions. Start with revising the concept of a fraction. And this task gave them the opportunity to be inventive and creative. We compared different solutions, found the most elegant ones, the most efficient ones. Number lines, these are fractions. Surprisingly, many children don't realize that fractions are numbers, so they can be put on the number lines. And we work with these charts by finding the fractions, seeing how they're related, which ones are equal, which ones are bigger or smaller, comparing and ordering them. Also, this nice pattern of kind of, they say that that's like a tree growing. Well, there is something behind that, because it's a basic for comparing fractions with different denominators but equal numerators. Something that is not routinely done in school again. And once they are used to this visual tool, we ask them to work without it, hoping that they will build their mental model of fractions and their relationships. And this task should be easy for them right now. These are standard questions, finding a fraction of a number and finding a number, the whole, by its fraction, but we put them side by side so that the children don't get used to a specific way of doing the task. It's all about thinking at every step without trying to memorize what steps needs to be done. Word problems, more or less standard, but they are quite hard for an average year 5 student. They managed to do that because we worked a lot on understanding what fractions are. This task is about equivalent fractions, again for year 5. They might already know what equivalent fractions are and how they get them. However, they don't quite understand why this works, and why is the most frequent question they heard from me in lessons, and they're quite used to it already. So, for example, some bars are divided already, have been divided. And if you use this bar, which has been divided into 5 parts, it's quite a tricky task to show 2 9s on it. So they learn to appreciate that some denominators are closer related to each other than others. Well, this task sounds like preparation for multiplying fractions, but they're not ready for that yet. However, they can answer this question if they draw something, if they draw models and they reason with their model, with these models in mind. Geometry, again, we don't forget about geometry. Quite difficult for some children to realize how they should name angles, because the most important point in the angle is the vertex, obviously, and they try to put it the first, when in fact it should be in the middle of the name. So this is essential training for them. And of course, we don't forget any creative tasks. Drawing a pentagon with angles of 4 types. Not very difficult, but they're happy to do that. And the next one is hexagon with 3 reflex angles. It's quite hard, but they are very happy when they finally draw something and realize that that's exactly what the Mercedes logo looks like. Year 6, we started with revising order operations. That's an extremely important topic. Again, unfortunately, pupils in school just memorize this BODMAS or BODMAS abbreviation without understanding what it means. I prefer to talk about every numerical expression as a sum of terms. And we practice this without brackets, as you can see, and then they try to change the value of the expression by putting brackets in some places. So it's quite creative task as well. Then we moved on to creating numerical expressions, not just working with something that has been given, but creating them long expressions as answers to the word problems. This one serves more or less the same purpose, to remind them about the order of operations, but also it's preparation for solving equations later. Now they create not numerical but algebraic expressions. Some tasks are quite simple, but they should follow all conventions about algebraic expressions, how they're written, what are different equivalent ways of expressing the same ideas. Evaluating expression, and then again, I give them something for their creativity to be shown, because they need to create expressions. That's a good place to talk about arithmetic sequences as well, because the formula for the nth place is some basic algebra, and there are quite a lot in there that can be discussed. Here are the equations. On the left-hand side, you can see quite standard ones. The right-hand side might scare some pupils. However, they are not more difficult than the ones on the left. Just the appearance can be scary. And we do this together as well. Both simply looking and complicated looking equations. Year 7, we started with revising all operations with the fractions and decimals. And the challenge of this task is to do it mentally, which means that they have to be inventive, trying to do this not on paper, but in their heads. And again, the only way to do this is to rely on some fundamental properties of arithmetic. This is a standard task about decimals and their multiplication. However, we look at multiple examples where different ways of working out can be used, and they're quite happy to have this flexibility because they don't just memorize the rule, they rely on their own understanding. Again, that's the task about this one, the multiplying and dividing decimals. Then we moved on to negative numbers. This is quite a challenging task for pupils who just start doing arithmetic with negative numbers. And we discuss all different options. Yeah, again, creating expressions now that would produce the answer of -10 when some numbers are substituted. And this was, I believe, the last task of the term, where we looked at some quite abstract equations, trying to find out identities between them. So this was year 7, year 8. We worked with negative numbers, but unlike year 7, it was mostly revision because they're already familiar with that. However, again, it's not just produce the answer, it's produce the question. These tasks are interesting because they can be solved from the point of view of a year 8 pupil in many different ways. And we discussed these different ways. Algebraic expressions from sentences. They need to translate sentences written in words into algebra. Preparing to solve equations again. Equations with they have to produce equations in 2 or more variables here, which sounds unusual, but we also discuss what values could be substituted to produce the solution. Well, again, this is a typical task, but this is more of a revision for year 8. Oh, the same can be said about this one. This is a combination of very simple ones, the ones that are definitely covered in school, like the first on the left. And some that could be quite confusing. They need to see that that's essentially the same thing. It's just looks differently. And this is the task about finding area, and again, algebraic expressions. We need to practice a lot of algebra this term because next term we'll be doing equations and linear graphs and the connection between the two. So they need to be quite fluent in algebra. I think that's it, but I have some suggestions for children and you maybe to look at during the holidays. You can take a screenshot if you like. These are web resources. The first one is amazing. What they call online playground is actually quite serious. Mathematics is involved there, even though it looks very playful and colorful and very attractive. The second one is the University of Cambridge collection of problems, tasks, and activities. It's always in development. New tasks, challenges are added all the time. The next two are YouTube channels. One is for the author of popular math books, Matt Parker. And the second one is run by different people, mathematicians. They present problems and discuss solutions. It's maybe not all of this could be easy for your children, but most of it they should understand at least the statement of the problem and how important it is. Then there is GeoGebra software. I encourage everyone to play with it because it's such fun just to draw different shapes, to move them around. There is some opportunity for basic coding and animation as well. And the last one, it could be apps that downloaded. This is apps for geometry puzzles. The first one is about shapes on a square grid. The second one is about shapes on isometric grid. The tasks are to find the midpoint, to draw the angular bisector, using only basic tools, drawing a line between 2 points and using grid points as well.